Hello and welcome to day 2 of the Advent of Code. I'm Max. I am still a professional software developer, at least for today. Today we're going to go straight on to day number 2 of the Advent of Code. I again have not looked at any details about this today, so this is going to be interesting. Let's see how it goes. Cool. So, day 2, rock, paper, scissors. The elves begin to set up camp on the beach to decide whose tent gets to be closest to the snack storage. It's all about these snacks, isn't it? A giant rock, paper, scissors tournament is already in progress. Ooh. Okay. Rock, paper, scissors is a game between two players. Yes, it is. Rock beats scissors, scissors beats paper, paper beats rock. If somebody chooses the same shape, a round instead ends in a draw. Aha. Appreciative of our help yesterday, an elf gives us an encrypted strategy guide that they say is sure to help you win. The first column is what your opponent is going to play: A for rock, B for paper, and C for scissors. The second column, and suddenly the elf is called away to help somebody with somebody's scent. The second column you reason must be what you should play in response: X for rock, Y for paper, and Z for scissors. Z. Winning every time would be suspicious, so the responses must have been carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores of each round. Okay, so that makes sense. And the score for a single round is the score for the shape you selected. 1 for rock, 2 for paper, 3 for scissors. Why does rock score 1? That makes no sense. Okay, whatever. Plus the score for the outcome of the round: 0 if you lost, and 3 if it was a draw, 6 if you won. Okay, that's quite interesting. Quite an interesting scoring system. I'm not entirely sure that that's a sensible one, but okay. Since you can't be sure if the elf is trying to get to help you or trick you, you should calculate the score you would get if you to follow the strategy guide. For example, supposing you're given the following strategy guide: A, Y, B, X, and C, Z. In the first round, this strategy guide predicts and recommends the following. In the first round, your opponent will choose rock, A, and you should choose paper, Y. This will end in a win for you with a score of 8, 2 because you chose paper, and 6 because you won. And in the second round, you'll choose paper, B, and you should choose rock. You lose 1, so the score for a loss is 0, and you score 1 for that. And the third round is a draw, with both players choosing scissors, giving you a score of 3 plus 3, which is 6. And in this example, if you were to follow the strategy guide, you would get a total score of 15, 8 plus 1 plus 6. Okay. What would your total score be if everything goes exactly to your strategy guide? I have already downloaded the strategy guide. That is here in our inputs folder. Wonderful. That is several thousand lines of rock, paper, scissors outcomes. Wonderful. So I think what we're going to do to start with is start with this. So let's go to tests. We're going to make a new file, day2.rs. We are going to do a pretty much similar thing than yesterday. Going to use our new code, make a step 1. If we were being super awesome, we might even come up with some clever way of doing this, but it's fine. Right, get back into our inputs. We want this input. This is exactly the same. It's just a cut down version of our input here. So we're actually going to do test. We're actually going to do another one. So we're going to go example, which is going to return a result and a box. So what I'm doing here actually is one of the nice things about Rust is that you can convert. If basically this is catching any error at all and is just throwing those, or at least returning them back up. So any error that could be raised that implements the standard error traits can be put inside a box and then returned up, which is quite a nice way of just saying catch everything. which is quite cool. So input equals, I think I can do multi-lines. I think I can do multi-line strings like this. We'll see. Let's see. Do a hash? No. Does that just work? Maybe that just works. I'm just going to finish it for now for okay. I'm just going to print that out, make sure that looks okay. Print the output out, and I should just be able to. I'm wondering if I can I run? Oh yeah, I can just click run test. There we go. Much better. Could not compile advent of code. Why could you not? Oh yeah, because I'm being dumb. It's fine. There we go. Try again. And now it's going to build. Hopefully going to build. Let's try that again. Hopefully going to build. And okay, so that good. So that we at least have the string containing our thing. What we actually want to do is get that as a, because we're going to need a vector of lines, right? That's the important thing we're going to need. Lines equals. It's going to get input. We should be able to dot split that. And a pattern is going to be a new line. And then I don't know what we get. Oh, we get a split. Okay, so can we have into iter? Let's see what we get out of that. That's an x, and that's a dot str. So we're going to do x dot to string in there, and then we're going to do a dot collect. We're going to say this is a vector of strings. That's all magic. Good. So lots of interesting stuff here, and also Clippy is complaining it a bunch of stuff. So vec lines. So we start with that input. Our input is just a basic string slice. So it's not a full-fledged, not a full fat string. It's just a string slice, which is, there are two different types of strings. I'm just see if I mouse over it. Is it actually going to explain what a str is? Possibly not. That's a bit annoying. But yeah, in Rust there are two different types of strings. Actually, there's more like three. But so yeah, the strings are like the mutable ones. They're like containers of string data, and so there's, in the same way like a vector has a slice view, an unstra is like a view into a string. I think it's like a nice way of saying it. I'm probably completely wrong, but it's how I'm thinking about it right now. Anyway, so we have this. We can split that up. So we're going to split by a character. This is it should be a character. A single character constant used as a pattern. So it's going to say try using a character instead. So I do. Good. We're going to turn the split into an iterator. And then from that iterator, we're going to convert all of our string slices, so they're the bits in between, into actual full-fledged strings, and then we do that. So if I do this and then print the debug version of veclines and run the test, then you'll see we suddenly have a vector that is split up into AY, BX, and CZ. Now, good. So that is the input that we're going to get from reading the file. And in fact, if we have a function called calculate score, what we can say is that this operates on a vector of lines. So, or indeed a vector of strings, possibly even a reference to a vector of strings, because we don't actually want to be taking. Well, we don't have to take ownership of it. Is the thing. Ownership is a big concept in Rust, but it's probably too big to be thinking about right now. So calculate score. It's not going to return anything at the moment. It will do later, but it's not at the moment. So I'm going to do that. Print out lines. And so we're going to call that with calculate score on vec lines, and we're going to pass that as a reference. And then in step 1, we're going to do pretty much the same thing. Let vec lines equal advent of code, read lines, and then we're going to read in our input from day 2, day2.text, and just bubble up the results. So we're just going to end up with a vector of strings, and then we're going to do exactly the same thing. We're going to say calculate score, vec lines. So for one of these, we're going to get just the example. So if I do run this, there we go. We have 3 little bits, and if we run this, it's going to give us a failure. Interesting. No such file or directory. That's because it's called inputs. But error catching. Told you it was useful. And there we go. So now we have a very we have a very long set of values. So as we come in, so what we need to do now is we need to convert these into pairings. So we have B and Z. So we know the sort of like the lookout of this is going to be a letter, a space, and then a letter. So what we can do for each of these is actually go through, and we should be able to map each entry into its score. We should be able to score it essentially. And in fact, there's a couple of ways we could do that. I think let's go for the nice. We want to write maintainable code, nice maintainable code. So we're going to split things up. We're going to write sensible functions. So first things first, we want to map each entry. So lines is a vector, so we want to iterate over that, and then we want to map each entry in that. So we're going to call each of these an entry, or call it a round, because it's a round. That's what the game called it. Okay, so we know that round is a 3-character string. So what we want to do is basically access the well, we can do 2 things. We can either access the bytes at precisely the right location, or we could split it up. So I think splitting might make more sense. Just trying to think if there's any reason why that would be bad. Now, this is quite interesting as a concept as well, because actually, in theory, this is a hard problem. Like in C, like ANSI C, not a problem at all. You just go like index 0, index 2, bosh. These are UTF-8 strings, and therefore, if we were expecting some weirdness here, you could quite easily have an emoji space another emoji, and then trying to index byte-wise into that would be actually quite hard. This is fairly straightforward. Like there's unfortunately getting around that is difficult, but we should just be able to split on the standard space character here. Let's. Well, for a start, we can just have it see what happens if we do a round.split. There might even be a split white space. Split ASCII white space. Split once. There we go. Split the string on the first occurrence of the specified delimiter and returns the prefix before the delimiter and the suffix after the delimiter. Excellent. So we're going to make a space, and this is going to give us 2 options. If I remember rightly. If we do this, we can actually save it. Yeah, so it's going to get okay. It's actually giving us an option of a string and a string, which is good. That's so what this is saying is the split once is fallible, but it doesn't return an error. It instead either returns some, which says yes, you had this, or it's going to return none. If it matches, I assume. If it doesn't match at all, yeah, so config.split once on an equals. There is no equals in the string config, so that's going to return as a none. So this looks good to us. So we're going to end up with this. What are we going to actually get from this? Just trying to think the next thing. So we could just write unwrap here, and then it's that kind of works. I'm just wondering if it's like if that's the best thing. I think the answer should be that just works because we have a well-known input here. So another option is actually, I think, if we do .ok and we do it like this. So what we actually, if I do a let x equals this for now, what we actually end up with here is it should end up with an iterator. There we go. We should end up with an iterator of round.splitones.ok. Let's say this should work, right? This is where suddenly I'm like, I'm pretty sure that works, but we can have a look. Oh, is it okay? Oh yeah, okay all, and we have to map it into an error. Right. Okay. So we actually have to have an error type. This is interesting. So now we can talk about error types. And now we can add more things to our code. So first things first, we get to add some dependencies to our code. And if you've never added dependencies in a language, well, if you ever worked with dependencies before, you know how much of a pain in the backside it can be. Here I'm just going to go to cargo add this error. And we've just done it. We've just brought it in. It's fine. It's all good. So now I'm now gonna create an error type for our thing. So we're just gonna go pub enum. This is going to be an advent of code error, and so an enum is like an enumeration. And I'm just going to do one which is just going to be generic string, and to make that implement. To make that implement errors, I should be able to use this error. So use this error, and then this. Oh yeah, there we go. Derive error. Well, that's what I actually want to do. Right, good. So this is a magical package. This package basically implements all of these standard error types that we care about on our code. So I can write this and go generic error. I think I can even do that, and that is going to give us an error type. And error types are special. They essentially have to implement a number of traits in Rust. So they have to be able to have they have to be able to be displayed. They have to sort of implement from the baseline stud error trait. So the rest of the infrastructure knows how to deal with them. So one of the nice things about this is that I should be able to do this and say AOC error. So what we're seeing here is that we're going to have an error. Oh no, that is bad. I'm just going to make this come on a new line so we can actually see what's going on. So the error is going to be, in fact, it should probably be OK or else. I think OK or else is acceptable. We'll see. Come on. Okay, having to compile because it's getting a bit silly. Right, there we go. And now we only need a predicate, so that's fine. And AOC error generic, and that should be failed to split. Well, round not as expected .toString. Unfortunately, because it's expecting a string, we have to do it this way, which is a little bit annoying, but that's fine. Cool. So what does that mean? We're actually going to end up with an iterator of results plus option tuples. Not ideal. So what we can actually do is at the top level, well, actually at this level we can say collect, and what we're going to do is we're going to say actually we have a result, and that result is either going to be a vector, there we go, of string pairs, Okay. Or it's going to be an AOC error. And the code just goes, the code hopefully, once I get the right number of brackets, says, yeah, that's fine. There you go. So the result in our return of that basically says either we have a good, either it's working, we have a vector of these things, or we have an error. And because I'm in Rust, I can put question mark at the end of that, and we can guarantee that actually what we're going to get out of it should be a vector. But the issue with that is that obviously now it's going to complain because, oh no, you're not actually returning an error. So what we're going to do is say this is a result, and what we're actually going to end up with, we might as well do like a U32 at this point. So I'm going to say it's a U32, or it's going to be an AOC error. Those are the return types for this. And we're going to say, for now, OK0 is our value. So in theory, we should be able to rerun this test, and it should all, it should all just work. And of course it doesn't. And that's because this code doesn't compile. That's fine. What I've actually done there is be stupid. Okay, and now we're saying AOC doesn't inform debug. Okay, so what I also need to do is implement debug on this, and it should be fine. Positional arguments, no arguments were given. I think there's some syntax I can actually do to make this work, and I do not know what it is off the top of my head, so I'm just going to ignore it. And now we go back over here, and field expressions cannot have generic arguments. Okay, if you say so. Oh yeah, there you go. I actually need to call functions. That's how functions work. Good. So all the rest of this, all good. And if I rerun this, we should have an X. It's going to complain because we're not actually using it yet. If I print out X, however, and rerun this test, we should end up with a set of separated strings. Hooray, good. So what we're going to do is I'm going to call that pairs for now. So convert lines into tuples. In fact, they're tuples of letters. And now we want a way of mapping our we need a way of mapping into like rock, paper, or scissors, right? And then we need to work out the combinations. Like, what happens if I pass a combination of letters in, like, what is the score? I need a score, basically. I need scores for a tuples. So let's do fun score tuple. In fact, it's we'll call it a score pair. And we really want to try and convert these things into we want to really try and convert these things back into sensible types as well. That would be nice. Is it always going to be the case? Let me just go back to the docs. Is it always going to be the case that our opponent is choosing from A, B, and C, and we're always going to be always going to be playing in response X, Y, and Z? Okay, so I wonder if we can do some really cool, funky stuff. Let's do some cool, funky stuff. Let's do another enum, which is going to be called what are we going to call it? Rock, paper, scissors. And let's call this, so we're going to have opponent rock, opponent scissors, opponent paper. We should probably do those in order. They have a natural order. Let's do that. And then we're going to say us rock, us paper, us scissors. There we go. And I mean, there are only like 24 variations here. We could just like manually go through and just work out all the variations. it is actually relatively tempting. I don't think we're going to do that just yet, but we'll see. There's a nice thing we can do is we can actually write some types for the rock paper scissors type. Just wondering if we could do like from str. From string. Let's do an anstra for rock paper scissors. Good. So a from is basically a way of converting from one thing into another. So what I'm saying is that there is a way of converting from a string slice into a rock paper scissors. In fact, I'm just going to do an error case as well, just because I know there's well, actually no. Again, we could, if I was writing, if I was writing proper code, I would have an error case. So you know what, I'm going to have an error case. So from our input, we're going to go from a self type. So I'm thinking we should be able to do string matching. I will just double check. Let's just do Rust string matching. So I should be able to convert to match against string slices. There we go. So yeah, good. This is what I wanted to do. So if I go match input, we can do what's called pattern matching. So I know an A is going to map to opponent rock. There we go. Self opponent rock. I'm going to know a B is going to map to self opponent paper, and a C is going to map to self opponent scissors. And the same thing for us. So we're going to an X, that's going to map to a self us rock. We're going to have a Y, and that's going to map to self us paper. And we've got a Z, and that's going to map to a self us scissors. Right? Those types should match what we had here. Yeah, rock, paper, good. Yeah, it's fine. So, and then what we're saying is anything else is going to be a self error case. That's just a hedging your bets, but we shouldn't actually ever hit that case. That means that we had some issues. Good. What are you complaining about? You shouldn't be complaining. Go away. Oh yes, because I haven't actually made a function. Hooray. So what else could we actually do? So we have got a dot collect here, but if we were being like super nice about this, we could actually do another map. And what we end up with, we have an opponent and us. And close that and make some brackets. Let's just do that for now. Comment you out. So I'm hoping. I'm hoping. Oh no, because it's a results type. Oh, that's a pain. Can we get around that? I mean, the only way I think we can get around that is moving this collect up here. So we collect the vectors, and then we end up with a vector again, and then we start going through the iter again, and then we do another map. So it's not pretty, but it will do. There we go. So we have. If I do into iter, actually, that should give us the string slices we want. So what I'm going to do now actually is pull in the rock paper scissors that we just had, and then say we're going to map from the opponent. We're going to map it just directly into rock paper scissors from opponent, rock paper scissors from us, and that should give us some types, which would be nice. If I go to dot collect here as a vector of tuples, or we need to call this as well a vector of rock paper scissors, rock paper scissors. Hoping this is just going to work. It's going to Oh yeah, we need to actually put those in double brackets, and then we typecast. Okay, good. So we have a vector of maps now. If I actually call pairs and we print this out, we should, assuming there are no errors here. Why are you complaining? Advent Scissors doesn't, rock paper scissors doesn't. All right. So what I'm trying to do here is print out debug information on rock paper scissors, and you'll notice that I haven't actually done something called derive. What this is basically saying is I can print out debug information about the thing underneath it, and you can automatically derive debugging information if everything underneath it is debuggable. And because we haven't got actually any types here associated with these should all just be debuggable. So as I say that, we should just do this, and we can run this. And what you see is that we end up with opponent rock as paper, opponent paper as rock, opponent scissors as scissors. Okay, awesome. So, is that useful? Is the first question. It might be more useful to just map them to their to the actual types, because then we only need to do 3 comparisons or a few comparisons. Yeah, that makes more sense. So actually mapping to these to different types doesn't make a huge amount of sense. So if we just delete these, what we can actually say is this. And unfortunately, what we're doing is we're throwing the semantic information away. We're throwing the semantic information away from the type, and we're putting it into the caller. So the caller has to know who belongs to who. But it does mean that our comparisons are better and easier. Now, we could put comparison functions. We could put comparison functions on one of the types. We should. Yeah, we should actually do that. Let's do that. So what I'm going to do is put an impl on rock paper scissors. What that means is we are defining methods for a rock paper scissors type. So I can't remember if I need. I think I probably do need pubfung. Okay, and so let's call a fight function. So I should be able to do self. I think that's right. Might be capital self. Nice. There we go. And self. That's what I wanted. I want a reference to ourselves. We do not want it to be mutable. We're not editing ourselves. We just want to view it. So if I do opponent as also a reference to a rock paper scissors, so we should be able to give out a score for us fighting our opponent. Yes, we should be able to do that. So we're going to give out a U32 value based on the outcome of the result. And let's not forget the result. The scores are as follows. You get a point for the shape you selected plus a score for the outcome of the round. Okay, so let's put that in a comment, because that is important contextual information that if you come to view your code later, you would be absolutely annoyed if you did not have that context. So putting that as a comment above your function, always a good idea. So a unsigned 32 value. I mean, it doesn't have to be that big, but you know, it's good. I mean, you could just do U size for now, but it's fine. So let's start off by get score for shape. Okay, and so we are going to do let shape score equals. We're going to match. We're going to match on self, and depending on the shape, the shape type. What are you missing? Oh yes, actually just match on this. So what we can do is control fix. It's saying, oh, you're missing a match arm. Fill the match arms. There we go. Magically fills all the match arms for us. And so our score is going to be on a rock. It's a 1. On a paper, it is a 2. On scissors, it is a 3. And on an error, I'm going to say a 0 for now. Good. It's by default calling that an I32. If I force that to be a U32, that'll just be fine. Okay, so now we need to get a score for the round. And one of the nice things, get score versus opponent. There we go. One of the nice things that we can do about this is we can use pattern matching, even more pattern matching. Hooray. Let fight score equals match. Then we're going to do self and opponent. Okay, so let's do some funky stuff. I wonder if I do this. Oh, IDs. I love IDs. There you go. Those are the combinations. Let's get rid of the error ones. What I'm going to do is get rid of the error ones for now, because we can edit, we can basically handle everything else as a 0. Okay, so what that is saying is everything else, if we haven't matched one of these, that's fine. So rock versus rock is a draw. A draw is 3. Rock versus paper is a loss. Rock versus scissors is a win. Paper versus rock is a win. Paper versus paper is a draw. Paper versus scissors is a loss. Scissors versus rock is a loss. Scissors versus paper is a win. Scissors versus scissors is a draw. So all we've done there, that's great. All we've done there is essentially combine. We're saying what are the combinations we can possibly have out of these, and there are only 9 of these. And we're matching up. So anything on the left here is what we got, and anything on the right here is what our opponent got, and obviously that's how the fight comes out. And so our total score is just going to be, you know what? If I just do this, if I just end up this function by saying shape score plus fight score, and we'll just say return total score. There we go, and then automatically Rust knows, oh, actually you did want an unsigned 32. That's fine. I guess I'll give you one of those. Fine. Good. So now that we have these, and now that we have these values, I guess what we can do is say let opponent equals, well, actually no. Let us equals rock, paper, scissors from us. There we go. So now that is a rock, paper, scissors type, and then we're going to give out, we're going to output the score from fighting. And so that's going to be us.fight, and then rock, paper, scissors from opponent. There we go. So that is going to give us, that's going to give us an iterator of unsigned 32 values. And as we know, we can just do a sum on those to get out score unsigned 32. That should work. So I'm hoping. And I need to borrow. Oh yeah, it's because I actually need to put a thing there, and I print the score out. So for our example, our score was 15, right? And we get a 15 out. Fantastic. So now, actually, I just want to be returning the score. I can even get rid of this type coercion because it's going to get the type coercion coming from here. That's good. I can get rid of a few more bits that are causing errors. There we go. Let score equals calculate score question mark println example scored score. Good. Just rerun that. Should work. Yeah, example scored 15. Fantastic. And there we go. And we're going to say step 1 scored that much. One final thing. We're going to see what this last little error is. I'm assuming it's because I'm using this, and what I could be using a slice. We could automatically be turning it into a slice of strings. And the code is pretty much exactly the same. It doesn't really matter. But yeah, that's fine. So we'll happily take that win, and we'll run the test on part 1. And step 1 core scored 12,645. So I go here, we put this in, and we hope that is the right answer. Woo! Okay, you're 1 gold star closer to collecting enough starfruit. Let's continue to part 2. Anyway, the elf finishes helping with the tent and sneaks back over to you. Anyway, the second column says how the round needs to end. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good luck! So the total score is still calculated in the same way, but now you need to figure out what shape to choose so the round ends as indicated. The example above now goes like this. So in the first round, your opponent will choose a rock, and you need the round to end in a draw, so you also score rock. Oh, okay, so it's actually a different meaning. Okay, good. They're changing the meanings as well. This is going to be interesting. That's fine. You need to choose rock, and you need the round to end in a draw, so you also choose rock, and this gives you a score of 1 + 3 = 4. Now you're correctly decrypting the top secret strategy guide. You would get a total score of 12. Okay. Excellent. So now we know. Let's do I need to I probably need to record this down, because I'm gonna forget what this means if I don't. So I'm just gonna write this, come over to day 2. We'll duplicate this. This is our step 2. And I'm just going to paste this. There we go. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. So where I've actually done all this here, then the calculate score, it's not technically entirely excellent. There are different things we could be. Jesus Christ, there are so many windows here. Let's just close some of those. Don't know what's going on there. So what is useful between these things? I think getting the results, mapping the results into a tuple is good. So we're going to do split tuples, split into tuples, lines, string. In fact, I'll just copy the end of that, and that should be fine. Okay, so convert lines into tuples of letters. Should be able to copy and paste this in. I remove that and I go, the result type is a vector of strings. Yeah, should be okay. This is where it's going to say, oh no, it's not okay. In fact, I think if I do that, we're good. Excellent. Yeah, just remove the error type. We don't need the error type because it's automatically returning an error. In fact, if I wanted to be super awesome about it, we just do that because it's magically determining the type. So now we have a function which splits our lines, which are a slice of strings, into a vector of 2 matching strings. Essentially characters, but close enough. So that is useful. So calculate score. Let's call this calculate score step 1 because actually it is. So we're going to say this is split into tuples from lines. Question mark, and then we're going to map that into iter. Okay, so that gives us the right fighting from our opponent, and that gives us the right values. That's good. So step 2 is more interesting. Step 1. Yeah. And in fact, we want to duplicate our example because we now know there is a step 2 example. There we go. Just to differentiate things. So in step 2, we split it into that. Then we have rock, paper, scissors for our opponents. And then we have the outcome. So we want an outcome, right? So in theory, we can come out with... can we come out with like... Oh, interesting. Let's come out with an outcome. So win, loss, draw, or an error. Now I don't know if I can like give these values. It'd be interesting if I can just give these like unsigned 32. Expected type found 6. Yeah, I can't just give it I have to actually give it a proper value. This problem without pattern matching is much more annoying. Yeah, I feel like it must be, because the ability to be able to just do this is so nice. Anyway, so outcomes. So win, loss, draw. We're going to do a similar thing as here, where we map from. So we know from our docs comment. We're going to import this for outcome. X means you need to lose, Y means you need to end around in a draw, and Z means you need to win. So X is loss, Y is a draw, and Z is a win, and anything else is an error. Good. So now we get to convert our... I'm just going to do that for a sec. Go to our step 2. So us, we're going to map us. Actually, us is not us. Us is outcome here. So let outcome equals outcome. If I just hit enter there, it's automatically going to add it to the top as well, which is another really nice feature. I don't know if that's VS Code or whether that's just standard. Like Rust Analyzer or something like that, but it's very useful. Okay, so we've now converted this into an outcome. So what do we actually care about doing with this? So we now need to figure out what shape to choose so a round ends as indicated. So we have basically an input of oh right, so we have an input of we have an input of our opponent and the outcome, and we need to spit out the right choice. Okay, yeah, it's pattern matching. Yet again, pattern matching. I'm just going to copy and paste this so I can get it through my head as we come to the values, and then we should be able to feed it back into the fighting thing we did before, which would be sweet. So import for outcome. And we're going to call it determine shape, and we're going to say self and self, and our opponent is still going to be a rock, paper, scissors, which is nice. So in the first round, your opponent will choose rock. I'm just going to do this as well, just so it's all on one line, vaguely on one line. Okay, so your opponent will choose rock A, and you need the round to end in a draw, so you also need to choose rock. So, so we need to match on ourselves. Oh, okay. You know what? I'm gonna let the algorithm sort it out for me. So match self bracket opponent. There we go. And I'm just going to go through, and the match arm's going to tell me what I need to do here. There we go. There's not many of them, and I can get rid of the errors as well. So errors, all of those errors can go. And Yes, we're going to end up giving it back a rock paper scissors. So that's going to map to a rock paper scissors error. Any errors map to rock paper scissors errors. Okay, so a win and rock paper, and our opponent chose a rock, so we need to pick scissors. No, paper. I can play rock paper scissors. A win and our opponent picked paper. We need scissors. Scissors and our opponent picked scissors. A win and our opponent picked scissors, so we need a rock. A loss and our opponent picked rock, so we need scissors. A loss and our opponent picked paper, we need to pick rock. A loss and our opponent picked scissors, we need to pick paper. The last one. The only missing one, nice. A draw. Oh, okay, these ones are easy. So this is rock. This is paper. And this is scissors. Okay, so now we have a nice, easy way for any given outcome of spitting out the matching shape that we need to be. So let us equal outcome dot outcome dot determine shape from rock paper scissors opponent. There we go. So that's going to give us a shape type out. Why are you complaining? Consider removing the borrow. Oh right, yeah, because I didn't actually do a borrow this time because reasons. I probably should have. In fact, I will, because fundamentally that is the correct thing to do. We do not need ownership of this. There is no need to take ownership when you're determining shapes of using an opponent piece of information, so that's fine. And especially because we're about to need to the opponent again, actually. So I do not want to be doing this in here. I do want to be doing it outside. So let opponent equals this. So we're going to fight our opponent. And now, yeah, so that gives us a shape. And now we're just going to output the score from fighting, which is exactly the same scoring mechanism as before. So we fight opponent. And that should give us the value. So this should give us a 12, right? That was the same value as we had before. The ultra top secret strategy is a 12. And we run the test. And we scored a 12. Yes. Excellent. I like it when code works first time. I'm also very, very wary when code works first time. But, you know, that's, you know, it is what it is. Sometimes you do manage to get the code right on the first time. Not often, but sometimes. And all we have to do now is now we've proven that the example works, which is a very nice way of making, like, if you have a small piece of verifiable data, start with that and then work on to like larger values. And we just run the test. So we scored 11756. Is that actually, God damn it, is that actually the answer? And that is the right answer. Excellent. So that is pretty neat code. That was quite, I wouldn't say difficult. I think that'd be quite hard if you were trying to use that without some sort of like pattern matching. Obviously pattern matching makes that a lot nicer, and IDEs make that a huge amount better. And obviously we've written a lot of code here, but this code is, I would say, more maintainable than if we wanted to like golf it. I know golfing is fun. Code golfing is a way of cramming stuff down into the smallest amount of code possible. But what I like to think here is that we're sort of building up reusable blocks as we go along, and refactoring out when we need to. Like we split out this function into a sensible bit of code when we determined that we didn't actually need it between the two steps. You know, both of these needed tuples. This one works in a slightly different way to this one. But anyway, that is the solution. That's my solution in Rust to day 2 of the the Advent Code. So I will attempt to be back here at the same time tomorrow. We've been going for about an hour. I wasn't expecting to be an hour, but that is what it is. So yeah, hope you enjoyed that, and I'll catch you again tomorrow. Bye for now.